everybody has to.
Yep. Beautiful. So on these kinds of slope field questions on multiple choice, I think what I would try to do is try to eliminate things based on the equations. Okay, so like I'm looking up here, and in the top, when the top of a fraction is 0, that makes the whole fraction 0. Okay, so the spots where there should be flat slopes are when x equals 0 and y equals 4. Does that make sense to you? If this were the right one. So let's check. There are 0 slopes at 4, but are there 0 slopes at x equals 0? X equals 0 would be all along here. And do you see that there are not 0 slopes there? Okay, so then I'm eliminating this. Okay. Okay. So let's take a look at this one. Where would the 0 slopes be on this one? Y equals 0 and y equals 4. Okay, so 4, 0. Okay, this is a possibility. So then I need to look and start putting in some points and seeing if they match. Okay, so specifically, something that I notice is, I don't know, pick a random point. Okay, so 2, 2. Does it look like this would be 2 times 4 minus 2? Does it look, so the slope here would be just a slope of 1. I mean, it's kind of hard to tell, but a slope of 1 should be more like this, okay? And it looks a little steeper than that, okay? The other thing I want to check is, let's check a negative slope and make sure that that's negative. Like if I went down here where y is negative, do you notice these slopes are positive? Let's pick a point down here. So maybe pick some negatives as well. How about 2 negative, we'll say this is negative 1. Okay, so if I put that in here, I'm going to put this one, 2, 4 minus 2, 2 times, this is the same one, this is a slope of 1/2, okay. What I'm looking at is, I guess this one, I know it's not this one, because this would be x equals 0 again. Do you notice these both are kind of the same? What's the only difference? The y is squared, which means it would make some negative. That's kind of what I'm getting at. It's going to make some slopes that should be negative positive. And so what I'm noticing is like these are all positive down here. Okay, so like if, I don't know, if I put something in over here where the y was negative, when I squared it here, it would be positive. Whereas if I put it up here, like if I had y was negative 2, for instance, this would be negative 2, I mean y is negative 2. This would be negative 2 and 4 minus a negative 2, okay? So this should be 4 plus 2, so this should be a negative slope, but down here these are positive. Are you seeing that? Okay, so it should be D rather than B. All right. What are some other ones? Ashton, you're up. Brady, you're on deck. Or maybe as you're looking through, you can take time. Is there something you feel like you got right and you're not, not sure why you got it wrong? Mm-hmm. So a particle moves along the x-axis, so at time is greater than 0, its position is given to you by this function. What is the first time at which the velocity of the particle is 0? So I want to find velocity's derivative, yes? Okay. So when you're doing this question, what I notice is there's two functions. So when I'm doing the derivative, what's it going to involve? Product rule. Okay, so let's do it. So first, what's the derivative of sine? Cosine. First d second, and then plus second. D first. This would just be 12e to the negative 2 because its derivative is itself. But do you see how this is a negative t? So then I'd have to multiply by negative 1. Okay, and I'm going to be real honest with you. At this point, if you wanted to, I'm going to pull that negative out in front. Okay. If you wanted to, you could start just putting in values, okay? But what I want to point out to you is, if this were 0, those two things would have to be the same, yes? Do you notice what they both have in common that's identical? Yep. So what I'm looking for is on the unit circle, where are the sine and the cosine equal? Because that's the only way they would cancel out to give it 0. There's one spot, or one set of spots. Do you remember what they are? The fourths. Yeah, yeah. So 17 should have been pi fourths, which is letter A, and it is. Okay. You're up. Mm-hmm. 20 was a hard one. Okay. Now, did you guess?
No, I didn't. Actually, I had like...
Nice!
I had 8 on B.
Nice! Alright, so, which of the following can be true? And actually, I made a quiz. That's not going to be a real quiz, on AP Classroom that I'm going to assign. That's all like piecewise and limits and things like that, just for extra practice. So, Ashton, did you remember this kind of thing was is that what you were thinking? Good memory, good. When we see like something with an absolute value and the function, it's some kind of weirdo piecewise thing with a gap, and we looked at that a lot. And so probably the reason he knew that this limit, you crossed out A, you said? Yeah. Was because that means they might have a one-sided limit, but going from both sides, it's not. So we have to check at both sides. But let's just put something a little to the right in. Okay, let's 3. If I plugged in 3 minus 2 is 1, yes. And then 3 minus 2 is still 1/2. Okay, so from the right, it approaches 1/2. Okay, from the left, what's something to the left of 2? Should we plug in 1? Okay, so if I plugged in 1, I get -1, and then the absolute value of -1 is +1. Okay, so Ashton was right. These limits from both sides don't match each other, so the limit doesn't exist. Okay, tell me why you knew, you were thinking, no, I know it's like this kind of thing. Okay, so we call this a jump continuity. I'll tell you why it doesn't have a removable. A removable, they would have had to give you the dot. So a removable would do like, maybe would give you something like this. Okay, but then they'd have at x equals 2, f of x equals 7 or something like that, where they'd have to fold the dot. So if they are ever asking about absolute values, those are always jump discontinuities. Okay, good memory. How about 21? Did you guys get that one right? Okay, this is another thing I had on the docket. This is the definition of the derivative. It's asking, think about this, guys. What would happen if you put 3 in here? It would be over 0, right? So it's basically asking you, what's the slope as you get closer and closer and closer to the point? And I also have some practice with all kinds of derivative questions that I might give you this week too. Maybe we'll do those 2 little practices tomorrow. So when you're doing this, if I know that this is the derivative, I'm spelling that all wrong. Okay, what's the point that we're looking at? What are we getting closer to? What x value? 3. I need to do the derivative at 3. Go back in the problem. What was the function? ln. So I need to find its derivative and plug in 3. And what's the derivative of ln? 1 over x. So it should just be 1/3. It should have been a. Okay. Aaron, you're up. Oh, you picked, yes, but you picked the one that is even the lowest. 21% got this right. 24% got the one Ashton right that he was just talking about, the same one as Ashton. Only 18% of people got this right. Okay, and here's why. Because I don't think you remembered this. Shows up every so often. This is exponential. When we did the exponential growth and decay, this was its differential. Okay, but here's what I will tell you. If you forget that, you can always separate the variables and do it that way. Okay, so it says at time equals 0, the weight of the yeast population is 120 grams, and it's increasing at a rate of 24 grams per day. So we go and okay, if I knew it was exponential, if I remembered that, what do we know y sub 0 is? 120, okay. Okay, so let's eliminate some choices then. What can we eliminate? These 2, right? Okay, so then we have to ask her if it's increasing at a rate of 24 grams per day. Ooh, that's hard. 24 grams per day. Okay. Then the first day, after day 1, let's just do some figuring. How many grams would there be? If it's increasing at a rate of 24 grams per day. 124, right? k. Oh, that should be a 120, guys. All right. I know you don't have a calculator, but if I'm doing this, let's just leave it in there. 124 over 120. Do we agree it's going to be some kind of fraction? Yes. And then equals e to the k. What do I do to both sides then? Okay. That should give you what k equals. And I look at my choices, and I think we know enough about natural log. What I would say is that's not exactly equal to 24. So I guess it would have to be 1/5. Without a calculator, I'm going to just rule out possibilities, and I'm going with B. But that's a hard question. One that I don't know that, no, only 18% got it right. All right, who's up? Action. Let's do some, yes. Let's also do ones that a lot of people got right. So I'm going to ask some questions, and if you got it wrong, we're going through it, okay? Did you guys get question 1 right? Yeah, okay. Did you get question 3 right? Okay, that's a good thing. And then, which was the one we wanted to do action after that? Okay. All right. This is quotient rule. So we start low, D high. What's the derivative of 5 minus x? You must have just made a little mistake, huh? Did you write then minus 5 minus x, d low, 3x squared, square the bottom, and away we go. Is that what your setup was? Okay, so this would be negative x cubed minus 2. Don't forget this is going to be subtraction. Minus 15x squared minus 3x cubed. All right, so putting that together, a minus, this would be now plus. So negative plus that is 2x cubed minus 15x squared minus 2 on top. I'm guessing, did you just make a subtraction error on that? Yeah. Okay, 26. Oh, I'm so glad. Okay. So when you see limits on the test, and that last one, that hard one that we were talking about, that one had statements about the limit, yes? If you guys see limits and you get like infinity over infinity or 0 over 0, you should use the L'Hopital's rule. And the L'Hopital's rule is you're going to take the derivative of the top, the derivative of the bottom, try again. If that doesn't work, you keep going until you can get a fixed number, okay? So in general, if I put natural log of something in there, natural log is going to increase. That's going to go towards infinity, and this is going to go towards infinity. So the limit of the top is infinity. All right, now let's try doing the derivative and seeing if we can figure it out. Okay, so the derivative of natural log would be like 1 over e to the 3x plus x, but then I'd multiply by what's inside, which would be e to the 3x times 3, yes, plus 1. Okay, on the bottom, what's the derivative of x? 1. Okay, so let's simplify this. So on top, I have 3e to the 3x times plus 1. And on the bottom, now I have e to the 3x plus x. Okay. If you put infinity in, you're still getting infinity over infinity, right? These are both still growing. Let's do it again. What do you get on the top? Let's do the derivative. Well, it's 3 to the e to the 3x, but we have to do chain rule, times 3. What's the derivative of plus 1? Okay, and on the bottom, we have e to the 3x times 3, and this would just be plus 1. Okay. Now, do you see what's going to happen when I do the derivative the next time? Is this plus 1 is going to go away? Yes? All right, let's do it one more time. So now I have 9e to the 3x over 3e to the 3x plus 1. Let's do the derivative of the top. 9e to the 3x times 3. On the bottom, we have e to the 3x times 3. Now I can cancel things out. What cancels? Uh-oh. It's 3e to the 3x times 3. The 3's, the e to the 3x's, what's 9 divided by 3? Should be C. Did any of you get it right? Okay. I will tell you, it's multiple choice. There are shortcuts. Once I get down to here, I'm like, okay, these are both going to kind of grow at the same rate. And do you see that 3 out in front? So you could kind of shortcut it right there. But okay, you're up. Or do you guys want me to pick, give you ones that a lot of people got right and see how you did? Okay, so how about number 9? How did you do on 9? Oh, good old integrals. Let's see what we got here. They're asking which one's basically the biggest and which one's the smallest. Okay. So are we looking? And we have a curve. What are you thinking about right now? What were you thinking about?
The antiderivative is the area of the undetermined.
Good. If you're looking at a graph, which one has the biggest area? That's what this is asking. Okay, so let's look. 0 to 2. That's pretty big, yes? What happens when you go to 0 to 3? Ashton, do you know what it means when it goes under? What kind of value would it be underneath? Negative. Okay, so if I put these two together then, don't you agree that 0 to 3 is going to be less than 0 to 2 because I'm taking some off? So far I get that 0 to 2 is the biggest. 2 to 3 is all negative, right? Okay, let's put them in order. 0 to 2 is the biggest. Then what comes next? 0 to 3. And the smallest is 2 to 3 because that would be completely negative. All right, so now we got to look through all these choices. Whoa. Was it A? Did they put it right in A? Yeah.
No, it's not.
Wait, what? It's flipped. What did I do?
Because you've got 2 to 3 as the biggest.
Yeah.
Oh, no. Yeah. I would have made that. Did you, Ashton, maybe make a mistake?
I had to look around.
Yeah.
I
Did
picked A.
Is that why you picked A?
Yeah.
Yeah. You made the same mistake I just made. So that's tricky. It should be D, right?
It is tricky. That's really interesting. Those are your copies that were with me.
Cool. You just made a guest appearance on my video. All right, so let's see. We'll do one more on video. Then we can. What else? Did we do 12? 12. You did not. this. We were just talking about it. At what rate in gallons per minute is the amount of water changing at time t equals 3? Tell me what that means. Did I give you 2 times?
Instantaneous.
Yeah, if I only give you 1 time, that's instantaneous, okay? 2 times could be average value or average rate of change. 1 time's instantaneous. So we're taking the derivative and plugging in 3. So what's the derivative of 25? 0. And then this would be minus 2t, right? And then I plug in 3, negative 6. Okay. I did that for 25 minutes. Do you still want